All right, we got a nice question from user homework 1234567 8. Great username. This one comes from the homework help subreddit, and we have an equation: 2 times the sine of x minus 1 quantity times cosine of 2x greater than or equal to 0. And so we need x in the interval 0 to 2 pi. So copy this down. 2 sine x minus 1. We got 2 sine of x minus 1. And I think this is times the cosine of 2x. So either, and we want this greater than or equal to 0. So let's solve for the zeros. Okay, so either 2 sine of x minus 1 equals 0, or cosine of 2x equals 0. Okay, so 2 sine of x minus 1 will solve for sine of x, transpose the 1 to both sides, transpose the negative 1 and the 2, and we get sine of x equals 1/2. And so what angles does that happen at? Let's think of our unit circle. So that happens here, and that happens here. And those are the only ones in that interval of x from 0 to 2 pi. So that will give us pi over 6. And what is that? 5 pi over 6. Sorry, that's kind of sloppy. That should be closer to there, but you know. Okay, and then so for the other one, cosine of 2x equals 0. Let's do a substitution. 0. All right, let's go theta equals 2x, and then we'll ask the same question about theta. Cosine of theta, where does that equal 0? And so cosine of theta equals 0 at pi over 2 and 3 pi over 2. So let's say theta equals pi over 2, 3 pi over 2. Or, you know what, rather than that, let's say pi over 2 plus k pi. Let's leave it like that for now. So we go to pi over 2 up here. I'm pointing at the screen. Go to pi over 2 up here. And then every time we add pi, we'll go 180 degrees around the circle. And we'll end up at a location where theta gives us cosine of theta equal to 0, okay, at the top and the bottom of the circle. But what we can then do is we can substitute back in our theta equal to 2x. So we'll say 2x equals pi over 2 plus k pi, and then we'll divide by 2, and we get x equal to pi over 4 plus k pi over 2. And we want values that are within that window of 0 to 2 pi, I think, like that. Or so he put it inclusive, which I don't usually see that way, so make sure that 2 pi is not included. Make sure it is included in your interval before you submit this. And let's think of values of k that'll keep us in there. So obviously 0 for k would give us pi over 4. So x equals pi over 4 is our root. And then if we put a 1 in for k, we'll get 3 pi over 4, which is in the interval. And then if we put a 2 in for k, we will get 4 pi over 4. And then if we put, actually let me check that, so pi over 4 plus pi over 2 is 3 pi over 4, and then pi over 4 plus pi is 5 pi over 4. Almost led you astray there. 5 pi over 4. And then that is in the interval. And then we'll get 7 pi over 4, which is also in the interval. And I think that is it. That's the last one that's in the interval. So all of these should be answers. And in the thing, you had some, or I'm sorry, these are zeros. So we're actually looking for ranges where it's above 0. So 0 or greater than. So all of these will be included. Now, so a trick here is like, what I would do is I would take the derivative of this, but I don't know if you have any calculus, and then I would look to see at this point, is it increasing or decreasing? And if it's increasing, then I can assume that everything to the right of it is positive. If it's decreasing, then I can assume that everything to the left of it is positive. So I don't know, did you say you had calculator? Basically, what I would do is I would look at this and I would see what root it came from. So for instance, if pi over 6 is the root that I'm dealing with, I know this came from this term, this 2 sine of x equals, or 2 sine of x minus 1 equals 0. Okay, so I'm looking for sine of x equals 1/2, and pi over 6 does that. Okay, if I get something less than 1/2, that will give me a negative value. Okay, so anything in this part of the circle will give me a negative value. But then I know that everything is positive up here until I get to the next root. So that's actually an interval. So everything in, so x in this interval of pi over 6 to 5 pi over 6 will actually give me a positive value, okay? And then let's look at these intervals. So I know that these all came from this portion of the problem here at the cosine of 2x. So if I plug in pi over 4 into x, that gives me cosine of pi over 2, which is 0. And then if I keep going, I get negative values. So I want everything in between that, and we should do, so that gives us, that's 0 for k. So let's do -1 for k, which is minus 2 pi over 4, which is negative pi over 4. So from 0 to pi over 4 is 1, so we need, here I'll write it over here, x in 0 to pi over 4 gives us positives. And then once we get to x is pi over 4, that gives us 2 times pi over 4, which is pi over 2, which is where cosine is 0. And then it starts to get negative. And then at 3 pi over 4, which is actually, when 2 times 3 pi over 4 is 3 pi over 2, then we start to get positive again. So that's our next greater than or equal to 0. And then we keep going around the circle until we get to 5 pi over 4, which is actually 5 pi over 2. And then, so this is 3 pi over 2, then we'll get 4 pi over 2, 5 pi over 2, that's at the top, and then we start to go negative again after that. Okay, so this is the end of our thing here, and then 7 pi over 4 is actually 7 pi over 2 when we multiply by 2, so that's back down here, and then we'll keep going until we get to 2 pi. So, oops, 7 pi over 4 to 2 pi, which you said in your statement of the problem that is included, so I'll put a square bracket there. I know that got kind of crammed in at the bottom, and I wasn't very verbose about my reasoning for that, but understand that when we're dealing with all those roots that we got from the cosine of 2x, when you're plugging them back into the cosine of 2x, you got to think of the argument as being 2 times that root. So that'll help you picture what part of the unit circle you're on. You're not actually, when you're thinking about your unit circle, you want to multiply it by 2 before you start picturing it, or else you'll get the wrong idea. So hopefully that helps. If this video is terrible, just let me know, and I'll be a little bit more descriptive about the last part about validating our intervals and figuring out where it's positive. Good luck.